Hi, I'm Ned, and I've started streaming. This is a recording from my live stream over on twitch.tv/NedMakesGames. I'm live most Mondays, Wednesdays, and Fridays at 10 a.m. US Eastern Time. I'd love to see you there. Alright, hey everybody. I hope you've all had a good couple days. I've been pretty good. I think, I'm gonna stream without the webcam for now because my cat is up in the window in front of my desk, and normally I close it so the view's not all blown out, but I'm too I don't know, she's too cute for me to disturb her, so I don't know, whenever she gets out I'll turn the webcam back on. But so for now I'm working on some of my grass system. Yeah, so the last couple streams we've been cleaning it up because I'm kind of preparing to do some new stuff with it. But for now, we finally got grass to actually spawn in the game world. Right now it just shows up as green little squares, so I think the first thing we need to do is be able to define some more shape to it. And maybe add a little bit of simple lighting just so that we can kind of test things. And my main goal is to try out a new wind system. So once we've got a little bit more of the framework laid out, then we can start on that. And my previous wind system, like it would actually calculate wind on the vertex function of the grass shader, but that turned out not to be the best idea because since the wind wasn't dependent like solely on position, it was hard to calculate a good normal for it, so you wouldn't really get good like highlights. So this new technique is actually going to be only using like a transformation matrix, and so I hope in that way we can just use the normal vector as we can just put the normal vector through the transformation matrix and it'll give us a correct value. But okay, so what should we do first? Let's maybe do a really simple lighting. So I'll just do get main light dot the normal vector. Yeah, so this is going to... Okay. Well, it doesn't really matter. I was going to say this is not going to have like double-sided lighting, but we can fix that later. Okay, so in here, how I do it is we just set this tint. We would just do get, or I guess saturate, get main light, direction, the dot. Okay, the normal, which we don't have yet. Okay, so since the card tangent and bitangent are the x and y directions and the normal is just the z direction, so okay, so we do this. Yeah, everything turns black, but that's because the light is just, it's pointing at a pretty much a right angle. So if I change this, okay, oh yeah, okay, so that should actually be correct, but I guess it's the other direction. Yeah, so now when we do it that way, it's green. I guess it doesn't really matter, but okay, so, well, okay, I'm curious. So if we did like, This would technically be what it's supposed to be. Is that... Okay, so now it's invisible. Do I need to normalize it, maybe? Okay. Oh. I don't know why it didn't give me an error there, but yeah. Okay, so that, yeah, it was correct. When you do the cross product, the z direction, I guess that makes sense. So the positive z direction is away from the camera, so when the light points towards the camera, then it's matching. Okay, anyway. Okay, so now we have really simple lighting, gosh. So I guess what we want to do now is maybe have, yeah, maybe let's add in randomization for the, or at least just use the blade height. I think I won't use the variance yet. So we'll use the blade width and height properties for dimensions. And oh yeah, so I don't even have any of the options in here, but I guess that's fine because we don't really, I don't really want to add an option if it's not going to be supported yet. So I'll just add something for blade width and height. Okay, yeah, this will actually just be a float. Oh. Okay, so why are they invisible? That would make me think that one of these got set to 0. Oh. Yeah, I don't need the new there. Why is it not? It's like not giving me... Oh, it probably is giving me errors, but I have the game view over the console. Let's put the game view over that for now. Okay, that's too small. I want it to be able to see the individual blades. Okay, that's pretty good. Yeah, it's kind of always kind of annoying to test in the editor just because of that flashing. But I think that's because the refresh rate in the editor is not the same as in the game view. And I don't know, it's not... It mostly just matters what it looks like in the game view, so I don't worry about it too much, but... Oh yeah, we weren't even playing. Okay, so when we or in play mode it works better, so. Okay, so now maybe let's add a random twist. So basically we just want I think I already did something common, or I did something like this in here. Okay, so it just gives me a twist angle. Yeah, then here we calculate, given the twist and bend, we made like a transformation matrix, but the thing is, I think the new system. Okay, well, I guess this twist can be. Like tied into the bitangent and stuff, so. Okay, so yeah, we just need to get. Alright, well, this normal actually will be invalid after this, but. I guess I can use this because it just uses the seed and then a random value. Except I don't have the seed right now, so I guess I'll just use. Let's see. I guess we can just use the cull settings, but I won't actually cull. Okay. And then we can get a matrix to rotate it. So I really want to rotate this around the terrain's normal vector, but I'll just rotate around the y-axis for now. And okay, so now for this, instead of just using this straight value, we would multiply it with the twist matrix. Okay, well, since the twist matrix is rotated around the y-axis, this actually is just going to always be the y-axis anyway, but then float. And then the normal vector, I'll just actually use these values in a cross product. Okay, let's see. Undeclared identifier angle axis. Okay, there's too many debug logs in here. Oh yeah, it's angle axis 3x3. Okay, so now if we press play. All right, so we're seeing a whole bunch of different twists, and yeah, so you can see green and black, and that's just because the only some of them are getting any light. And if I rotate it, you can see the light changes. Obviously, this isn't how we'd actually want to light the blades. It's more just for testing, because grass is kind of transparent, so it would never be dark on one side, really. But, okay, so now we have a simple kind of rotation here. All right. No. Okay, so this is where it gets a little complicated, because the how I want to do it is I want the grass, first of all, to bend forward. So we kind of need to have a transformation matrix for the bottom points and then the top points, and then for the points in between, we'll interpolate between them. And then for the wind, I'm hoping I can add the wind into the top point matrix. And then yeah, I'll be able to. And then when we interpolate between them, since the wind is also stronger at the tips, it will look pretty good as well. So, okay. So the main thing I want to see is, like, how do I first interpolate between the two matrices, and then what's the best way to send both of the matrices over to the grass blade shader. So since I'm working with only rotations, I think I could probably represent these rotations as quaternions, which, so a rotation is a 3x3 matrix, that's 9 floats, whereas a quaternion only has 4 floats, so that's pretty big, like, in terms of memory, but I don't know how difficult it is to just rotate by a quaternion in a shader, because, I mean, I'd have to implement that formula myself. Let's see. Oh, I don't want to. Wikipedia is great, of course, but its math articles are really hard to follow. Okay, those aren't super good either. Okay. So is the quaternion times the point times the conjunction of the quaternion, whatever that is. Hopefully they'll explain. Or conjugate, sorry. Okay, so you can basically just transform it to the matrix rotation or matrix representation. Okay, I kind of just want the formula. Maybe I can find someone that has already written it in HLSL. Rotation around an axis. Okay, we'll probably need this. Okay, so this is about the same. So we have to do one sine and one cosine. Let's see, so for angle axis, yeah, we also have to do a sine and a cosine. Okay, there's a lot more math here, but I think that probably when we rotate around a quaternion, we might have to use all the, it might kind of even out. Yeah, it seems like it's gonna skip the. They go on to multiply two quaternions, but then they skip the part where we rotate. Okay, I guess it's just here. Okay, so there's this optimization, which is maybe what we want. Okay, so this, let's see. So to rotate around a quaternion. Okay, so we'll already have done this before. So you get the position. So it's the position plus 2 times the cross product of the real part of the quaternion plus the cross product of the quaternion times the vector plus W. Okay, well, who knows what all this math actually means, because quaternions are pretty confusing to wrap your head around. But yeah, so this should rotate. So I guess before we go any further, let's try to convert the code I already have to rotate with a quaternion, and that way yeah, we can see if it's identical. So we can represent a quaternion with a float 4. So angle axis quaternion. So they get. Okay, so you just half the angle, then you do a sine and cosine of half the angle. Oops, I keep on. Okay, and then it's just the axis XYZ times the sine. Right? Yeah, okay. And so now we need to rotate by Quaternion. Okay, and this was... Okay, so I already have that, so it's just P times 2 times cross. So, let's see. So it's 2 cross products. P plus 2 times cross the real part of the quaternion times the cross. Okay, I'm gonna... Okay, so... Okay, kind of interesting. Well, okay, I guess, yeah, we have the Q at the front there. I don't know if it really matters if you or if the compiler cares which way you multiply that, but... Alright. And then the other function I'll need is Quaternion interpolation, which is usually called SLERP. Let me see. I can find an easier... Yes, this is like the Unity version, but I don't think it tells you the source code. Again, Wikipedia is usually kind of confusing. Okay. So you need to find that angle between the two quaternions, which you can apparently do. Okay, it's basically a quaternion dot product. That is a quaternion dot product. Then if the angle is equal or is greater than 1. Okay, then it just sets the return quaternion equal to the input quaternion. Okay, so if theta is 180 degrees and the result is not fully defined, we could rotate around any axis normal to QA or QB. Okay, so what's it doing here? It's basically taking the average between them. Okay, so then otherwise it does like a linear combination of all the values. Is that similar to what was in... Oh, this is a... Okay. Well, I was going to check to see if it was like that other implementation, but... Okay, let's just implement this really quick. So float for SLERP Quaternion. And yeah, this is just a way to interpolate between quaternions when you're thinking about them as a rotation. Okay, so yeah, we can simplify this code a little bit. I shouldn't do that. All right, and then if so if the dot product is greater than 1, that means that they're, or greater than or equal to 1, that means that they're parallel. So we can just return either of them. Okay, and then we need to find the angle, which I think HLSL just has the arc constant. Or arc cosine. And then using trigonometry identities, you can get the cosine. I wonder if it would be faster just to take the sine of the half theta rather than doing a square root. I don't know, probably not, but... Okay, so if the sine is less than 0, that means that they're 180 degrees apart, right? So if theta is 180 degrees, then the result is not fully defined. And theta is the angle between them. So we rotate around the axis, normal to QA or QB. It seems like it... Okay, well, I don't know. I'll just do what it says. I am a little surprised because it doesn't seem like it's actually interpolating between them. But I guess... I'll have to figure out exactly how this function works at some point. I'm sure they explained it well, but... Okay, so this is basically just the average between these two, so I can just do QA plus QB times 1.5. Okay, and then otherwise we take the ratio of different angles. So this must be the spherical part of the SLERP. Sine 1 minus P times the angle and this one is just P times half theta. Okay, so then the final quaternion is just a linear combination of the two. So we can return QA times ratio A plus QB times ratio B. All right, so let's see. So before this actually, I'm trying to think like is it more efficient or not? Because before I was having to like pass different values and then calculating the angle axis every vertex. But now in the vertex, I'll basically be passing two quaternions, and then we do this SLERP and then a rotate. So we have two cross products and sine and a, or actually you pretty much just have an arc cosine and a square root. So I don't know, it probably isn't really that different, but we will be able to pass less data because we'll only be passing two quaternions instead of two rotation matrices. Sometime it'd be interesting to go and really I guess like what's it, profile and see which way is faster or not. But anyway, so this should be all we need with quaternions. So what I would do is instead of doing angle axis 3x3, I would do angle axis quaternion. Well, actually, I mean here we don't have to do a quaternion because we'll be passing the quaternion. But I kind of want to test it, so twist Q equals angle axis. And then instead of multiply. Oh, I haven't. Did I do? Oh yeah, rotate by quaternion. Okay. Okay, and it is faster to do it the normal this way instead of rotating by the quaternion again because when we rotate, we have 2 cross products, whereas here we just have 1 cross product. So let's see. Seems to work. You know, it might not. Okay, I mean, I guess I could try to switch between them with a keyword and see if the rotations are exactly the same. In this case, I don't really think it matters, but we might as well check. So let's see. If def use Quaternion. Otherwise, we'll do something else. Okay, so let's make sure I didn't break anything. And then in the shader, I need to just add a render feature for this and a toggle property. Okay. Okay, so now hopefully when I click this button, we won't really... Okay, they do change. Seems like... It seems like they're like backwards. So maybe I missed a sign somewhere. Or they're like almost reflected. Okay, so I wonder like if I just did that to reflect the angles, if it would be equal. Okay, well, that did kind of help. Now, see, now the only thing that's changing is the color because the normal vector is being reflected. So if I did something like this, Okay, one second. My cat finally got out of my window, so let me go and close that, and then I can finally turn my webcam back on. So yeah, one moment. Okay, I'm back. All right. Okay, so what I thought before is I could just flip the normal vector and they should be the same. So if I do something like this, yeah, so now they're equal. So I'm trying to think, what does that tell me? So could I get the same effect if I did a negative angle, because that would be a little easier? Okay, yes. It's a negative angle, but then some of the stuff is still backwards. So can I get the same effect if I negate these? Okay, no, if I negate both of them, then when I turn on Quaternions, there's like not a number or something. Why does that happen? Oh, because I think it's going like... Yeah, I think it's just that the bitangent is negative, so it's going under the ground. I mean, I guess it doesn't really matter that much if it's different. I mean, I kind of like them to be consistent, but I feel like... I'm trying to think what is weird about it. Or like, maybe one is using left hand and one's using right hand, but there's no... It doesn't seem like there's handedness in... Oh, I'm doing this backwards, so it's sine and then cosine. Okay, so hopefully that will just fix it all. Yeah, okay, so that was it. So kind of a silly mistake, but I'm glad that I found it now before it caused me a headache later. Yeah, because it's sine, cosine, so you put the sine first. All right. So, let's see. this is what I'm trying to do. So I guess I still need to do this card tangent to world, but does it really matter? And I guess the other option is I could just not pass these values and we just pass like the start and the finished rotations, and then we would just interpolate between them. Okay, let's... So let's see here. So to rotate a point around a quaternion, there were 2 cross products. I'm just trying to think, like, will this be a lot slower? And then we would have to do this interpolate, but I guess if I'm gonna, we'd have to interpolate rotation matrices anyway. I guess I should, I'll just see how much slower. Problem with this is that we'd have to pass 2 rotation matrices, and okay, this is basically what I just did. Okay, well they're just saying don't do it, so I guess we're kind of, yeah, we'll just do it with Quaternions. Okay, so in that case, so the grass structure, I just would not pass this. I would just pass the bottom and top rotations, basically. And then in here, okay, well this we're actually, I don't really have to do this slurp for this because we only are making 4 points here. When we add tessellization, we'll have to interpolate. So, let's see, so float 4. Equals, there's probably a better way to do this, but it's fine for now. Route dot tip. So something like that. And then I'll just keep this for now. And I guess this part. So now the position and world space would be rotate by Quaternion. Tangent space times that. Okay, and now in the grass feature, I need to change. So we won't use these anymore, and I guess I'll just comment them. Instead, we'll use float for root, Quaternion, and tip. And so we can take away the 2. All right. Oh yeah, so it's gonna complain now because these don't even exist anymore. So let's comment that whole thing out. So really all I have to do is just pass, if I pass the root quaternion as this quaternion I just did. And then the same thing for the tip. Okay, I'm not sure what that means. So dot, no matching two parameter intrinsic function. Oh, okay, so I still need the normal vector for lighting. Well, then I would just do load space equals rotate by Quaternion twist. Oh, I did this backwards. Did I do the same thing in the... No, the point first. Dimension of conditional does not match the value. Oh. Okay, and I don't use the math. But I think I'll just include it in Blade Common. Okay, so nothing shows up, so we've got some problem. Or, wait. They're all right there. Okay, yeah, I didn't apply the offset again. So... yeah, I need to just add the sprouts position. Okay, so it seems to work. Okay, so now if we vary the point or the quaternions, we should get some kind of rotation. So I got too much open. Let's just give it like the identity quaternion, which is 1110. Oh. Okay. Oh, they're underground. Yeah, maybe that's not the identity quaternion after all. Okay, well I am kind of, actually now that I think about it, I'm a little surprised this is working because we're still... Because the blades are given in tangent space, right? But that Quaternion rotation is just in world space. So let me check. That's not what I want. Here. For some reason I can't ever find this file. Okay, so the get blade. Okay, and the position in tangent space. Let's see. Okay, well this is kind of happens to work because right now the tangent space is the same as world space. Okay, but I guess that's fine. We just got to apply the transformation. Okay, so I guess that's the first thing we should do. We should kind of build up from this. So, I want... So if I want a rotation to rotate... actually, let's see here. So I kind of need to apply like this normal map and get the terrain's normal and tangent vector. Yeah, and then from there I can make sure that the grass points in the correct direction. Okay, so let's go ahead and we got this working. Let's go ahead and test out culling. I could just delete that and can delete this little test keyword thing. Okay, yeah, let's just do culling and not worry about this density at the moment. Oh, there's too many. Okay, so everything is being culled, looks like. This is a test that we can flip this around. Yeah, so everything was being culled. Oh, probably because I don't set any of the culling properties, so... So I need to make a property for all of these. I think I'll kind of copy what I already had here and then change the names as needed. Because it's kind of a pain to type out all this. gonna add something else there, but now I can't think about what it was gonna be. Okay, so I mostly just changed a bunch of these names. Okay, change this to Sprout. Yeah, the Sprout. I guess we'll just rename these, even though they're not really used. Kind of little placeholder variables. Okay. Don't really have to have LOD at the beginning since I have LOD in the header. Okay, it's cleaned up a bit. Okay, so now it seems to actually be doing its job. If I, so we can mess with some of these values. Not sure which one to use. Okay, yeah. I need to clean up those textures too, but I don't think it really matters. Okay, so now you can see the LED levels take effect. Undeclared identifier, Sprout LED, info noise. Okay, I think I just got the names a little mixed up there. Okay, so you can see this kind of just like makes the LOD levels have a bit of, they're not quite perfectly circular, so they're a little harder to notice. Okay, I don't think that one doesn't seem to be working, so. So when I move player forward, okay, you can kind of see if I bring this up. Okay. You can kind of see like pop in. That's what the width smoothing is supposed to do, but it doesn't seem to be working. So let me, or it's supposed to help with. Yeah, it's not doing anything. So let's see if we can fix that. Oh, it's not doing anything because I haven't put it in the system yet. Okay. Because, yeah, I just used the width and the height directly. So what I want to do is call kit sprout dimensions. Okay, so get sprout dimensions. So first is the random seed, then the base dimensions and the variance, which I need to add properties for. And then the LED level, which and then I think called next LED. Which I don't remember what the field is for that. Yeah, we'll call next LED. Okay, so now I need to add height and width variance here. Oh yeah, I also don't need to have blade at the beginning of both of these because we have the header. Okay, I guess I'll set these to 0 by default. Okay, so now we can see there's a little bit of randomness to their width. And the height. So now as we move in the world, okay, you can still see popping at the back, but you don't really see it in the middle where the LOD level changes. And if I turned off width smoothing, yeah, so you can see a big difference, but with it turned off, yeah, you can kind of see grass blades popping in and out as they get culled by the LOD system. Okay. Alright, so I'm glad the LED system works because I put a ton of work into that before and I don't know, I was pretty happy with it, so there's no reason to really change it. Okay, so now we can test out a density texture. So first we gotta get the UV. Still not worry about this for now. Now, do I have the... I don't think I have like a data map. Okay. Let's not. Oh yeah, I don't want the offset because it should just match the color texture. And I'll also mark this as being a normal map. Okay, so do I have... So I do have a pure white texture, which should mean that grass should always spawn. Oh, but I think the reason is there's a sprout density property and it's set to 0. Okay, yeah, that was it. So now when I move this down, you can see the density of sprouts goes down. And if I add like a noise texture here, you can see that also affects it. Pretty sure I have like a test, like a checkerboard pattern. Oh yeah. Yeah, so this spawns like stripes of grass. And yeah, that's because this density texture tells the system not to spawn grass in certain areas. I've seen pop in, so... Okay, so yeah, that's all pretty good. So now what I want to do, like if I have this block, okay, so it actually is moving. Yeah, I want this one, which is angled, and I'm gonna give it this same shader. So you can see if we press play now, the grass blades like don't follow the normal of the terrain. So what it can do... Yeah, so I guess that's the next thing we need to try to figure out. This is actually like the terrain normal, so this is more the blades normal. So I don't get it mixed up. And then, so we'll actually twist this around the terrain normal. Hey, thanks for the follow. Okay, got an error. Apply normal map. Cannot implicitly convert from float 3 to float 3 by 3. Trying to think, why would that happen? Because something doesn't exist? Oh, I didn't. I need to add this normal strength. Do I already have? Yeah, I should have a property for it already. Okay. No, I don't think this twist is working correctly. Oh, because, yeah, this is, yeah, because we're twisting around the normal vector, but the the card itself is still, like pointing straight up in the world. So when we tell it to twist around the normal vector, it doesn't actually like twist the way that I want it to, because I need to rotate the blade so that it's pointing along the terrain normal first and then twist it. Okay, so to do a Quaternion like that, I guess I need to do a look at rotation. Hopefully that won't be too hard. Oops. From 2 location might not be too difficult to do. This is quite a bit more complicated than using a matrix, but well, I mean, we can split hairs over optimization later, I guess, but because what we could do is, I don't know, just do a normal tangent space matrix and then convert it to a Quaternion. Maybe I should do tangent to world Quaternion and see if there's an easy way. This is the formula I use for rotating a vector. Okay. So this is Quaternion from 3x3 matrix, which is what you'd use for tangent to world. So it does square root. Okay, this is all pretty simple. So let's try this and see if it works. So float 4, Quaternion from matrix 3x3. Well, okay, let's just do Quaternion from tangents. Float 3, tangent, bitangent, and normal. Okay, so float W equals square root 1 plus, okay, so it's a diagonal, so tangent dot x plus bitangent dot y plus normal dot z divided by 2, and then return float 4. Okay. Bitangent dot z minus normal dot y divided by 4 times w okay, and then make sure that I'm cross-referencing this right. So call 2 is normal, call 0 is tangent, and then call 1 is bitangent, and then so zy xz, and then yx. Also, yeah, I need to make sure this is in parentheses so that the difference is divided instead of just the second term. Okay, so hopefully this code worked okay. But let's get rid of the twist and just make sure that they orient fine based on the normal and everything. Okay, well, oh, it's fine. Wait, is this? Okay. Okay, so I guess I'm going to ignore the normal map for now, because what's going to happen is we kind of have to calculate another tangent to world using the modified normal. But for now, we'll just use the actual normal from the mesh. So float 4. I think, yeah, I forget when you, I'm gonna have to see, but when you specify a matrix or by 3, I forget if it's, everything goes in by row or by column. Okay, so we just want to set this to this vector, or this quaternion. Okay, so I can't even grab it like that. I think it's this C in HLSL. No. Okay, fine. You know what, let's just grab it directly from URP. Oh, down here. Okay, so yeah, so this is what I wanted. So input dot W. Okay. All right, this is backwards. So tangent by tangent, and then input dot normal. Valid subscript normal. Oh, right. Okay, so no errors. But the grass exists, but it's at something weird's going on with it. It's inside the terrain. Oh, because this is the, yeah, so this is a Quaternion to rotate. Well, is this even the right direction? Yeah, so in this way, the normal vector, which should be up, is in the z, or the z-axis. But when we do our card, the z-axis is like the light direction, so it should actually be flipped a little bit. So I think I can get it to work like that. Okay. Why isn't there anything on the terrain though? It works fine here. Oh. Okay, I didn't update because the game view wasn't updating. Yeah, that flashing is what I meant by since the noise seed is determined by world position. When something moves, it makes the grass shimmer like that. But how come? Yeah, so why is there nothing on the terrain? I don't know why it would work on the small one but not the big one, because they both use the same material. So that would lead me to think it's something to do with the mesh, but the soil is just using a cube. It's the same as this one, just scaled. Okay. So it shows up when I scale it, when it has a negative Y scale. So that makes me think, was it like, is it inside the ground? But I should still be able to see it. Oh, it's static now, so. I mean, I'm not even using this part. Okay, so how come when I commented this out, is there an error now? No. So I'm just using straight from the input. Okay, let's think. So for the terrain, I mean the tangent says some vector on here. And then the normal vector is pointing straight up, so yeah, so that would mean Y is pointing straight up, so that should make the grass cards also point straight up because their up direction is in this Y. And now this part stopped showing up. Okay, let's Just try to get rid of as much variables as possible. So we'll just give it a white density map. That doesn't seem to do anything anyway. And then if I turn, like if I uncomment this, that makes the grass show up here. Okay, so it does have a normal map. I don't think it actually, well, it makes the stuff look different, but it doesn't actually change the, oh no, it does change the grass. Okay. It changes the grass's lighting anyway. Oh. Well, that's okay. So it's changing the lighting just because this twist still uses the normal world space. Which it should have thrown an error when I turned this off. Because yeah. Okay. So to fix that error, let's just do this. Yeah, because there's no normal. I don't know why I didn't throw that before. Okay, look, actually, modify tangent. Okay, so at least we got it to show up here again, but there's still nothing on the soil. Unless I give it a negative scale and then it shows up. Okay, only in the editor. Okay. I just don't know why it works for some, for that one, for this, and doesn't work for this. What about if I rotate it a little bit? Hi XT Zombit. It was fun to watch for a bit. Best of luck with the grass shader. Thanks a lot. Yeah, thanks for coming by for a little bit. I appreciate it. Will I be streaming this every day until it's done? I stream on Monday, Wednesday, and Friday, and probably will be streaming this mostly. Because yeah, it's kind of like my stream project at the moment. Okay. Let's start. Okay, let's just do something a little bit simpler. Get rid of this, and let's not even have this twist for now, and we'll. Okay, that's fine. And just to see if this works, we'll just do kind of dummy values here. 0, 0. Okay, XZ Zombit, that'd be great. But if you do miss any, I do upload everything to my second YouTube channel. So yeah, don't feel bad if you can't come. Okay, so when I did that, everything works. So that makes me think it's something weird with the mesh data. I don't know why that would happen, but... Thank you, you too. Take care. So let's just switch this stuff around and see... Okay, so... Make it now, it should grow around the x-axis. And just see if that works. Okay, yeah, so the x-axis is pointing to the right. So yeah, you can, it's kind of weird because of Z fighting, but you can see black grass cards. Okay, so at least they point the right way. So I don't think the matrix math is wrong. There's something about what I was doing here is wrong. Okay, I wish, well, let's see. Let's just output this as the color. And then we can see what is actually in the bitangent. I guess I should make this a little bit more sane so it's easy to see what's going on. Okay, so the bitangent. Okay, well, it's hard to tell because it's black here. So that means it's not Y like I would expect, which is a little strange. Well, okay, actually no, that's not strange. The bitangent for the terrain should be pointing along the Z-axis. So if I set this to negative... Okay, yeah, so it was the negative Z-axis was the bitangent. What about... Yeah, so just the normal vector. Yeah, it's green, so that's what we thought. Okay, then how come this works this way? Well, what about if I put the normal there? Okay. And then the bitangent? Okay, so something about the tangent vector is being weird, I guess. Okay, so I would think the tangent vector pointed in the x direction, so it should be red. Let me put it negative. Okay, so it's pointing in the negative x direction. I mean, that's shouldn't matter. But so how come when I put that in here, something it like just makes it disappear? So if I put -1, Okay, so something about putting a -1 there. Maybe I messed up a sign in this equation. I mean, what happens if this is negative? Then it would give you not a number. Okay, I mean, that's the problem, right? If it has a square root. I mean, and if all these were pointing in, like, this was -x, -y, and then -z directions, then you get square root of -1. Okay, let's see if I can find another equation for this. Quaternion from matrix 3×3. That's not very helpful. Oh no, I want this one. Okay, yeah, so matrix A is orthogonal. Yeah, if the transpose is the same as the inverse. I think that just, yeah, the matrix is orthogonal if each column in it is at a right angle, which that's what this would be. And normally rotational matrices are. But I guess this must be our error because I guess we can check. Because, okay, so I had the tangent space is -1, and then, yeah, the normal was positive, but then the bitangent was -z. So, yeah, I was giving 0. Oh. Yeah, so that's the problem, but okay, so I guess the issue, we could try to make something more resilient, but maybe, okay, in this particular instance, I don't really care because the X, yeah, I really only care about the normal. The tangent and bitangent can kind of just be anything as long as they're orthogonal. So I guess I could just do an absolute value of it, but okay. Okay. So yeah, maybe before we try to fix that. Yeah, because here we're already gonna have to calculate a new tangent and bitangent because I'm perturbing the normal with the normal map. So I thought this would be simpler, but okay, I guess it's not. Like I have this function that calculates an object world given a normal, which yeah, will change most of this code, but one thing I do here is I just pick a random vector that's orthogonal to the normal. And then you can take that cross product to get a tangent, and then you can take another cross product to get the bitangent. I'm not sure why I did the negative there, but let's just try this. So I don't know why that does actually matter. Okay, so to make sure this is all like the diagonal is always positive in that equation, I can just flip them if, yeah, okay. Because if I flip it, it'll still be orthogonal, right? And I don't really care if it's not. Because the other thing is the diagonal could be 0, but that would still be positive in the equation. And okay, so the other problem would be also if the z-axis for the grass is 0, but I mean, when are you gonna have grass that's pointing in the negative z direction? So okay, one second, my cat wants out. Okay, yeah, so if the tangent's next, oops, the tangent is negative, then we'll flip it. Same with the bitangent. Okay, and then we can just assume that the normal is not. Okay. Yeah, I guess I kind of. Yeah, so why would, I mean, you'd never, I don't know, we almost don't really need to worry about this because if the normal is negative, I mean, if the normal dot y is 0, then the grass is like horizontal, which wouldn't even be seen by the camera. So I think I'm gonna just comment that out, or go the way I did this. Now my other cat wants out. One moment. They're being quite funny today. Okay, so anyway, now that we've done that, we don't need to do this stuff. Okay, so hopefully this will work. So we want to grow along the normal. Okay. All right, I think that is looking better. So we finally got, okay, and you can see even though I've turned twist off, some of the grass blades are perpendicular to one another. I don't think that really matters. And that's because, well, why does that happen actually? I mean, it doesn't really matter because the twist angle will randomize it anyway, but... Okay, so let's try... Okay, so now I need... So to combine rotations, I need a formula to multiply quaternions. And I don't think you can just do a straight multiplication, unfortunately. Let's see. Multiply quaternion formula. Okay, no, thank you. Okay, this Euclidean space has turned out to be pretty useful. Alternatively, if we want to use scalar and vector notation for quaternions, we could define... Okay, so quaternion multiplication is the scalar values minus... Okay, so scalar A times scalar B minus vector A dot vector B, okay. And then vector A cross vector B plus... Okay. Okay, so I'm actually putting the scalar value, which is the W value at the end, so... we do A, X, Y, Z, or plus A dot W times B XYZ plus B W times A XYZ, and then the W part is AW times BW plus dot A XYZ B XYZ, or yeah, minus dot actually. Okay, so the scalars minus the dot product of the vectors, and then the vector part is the cross product of the vectors plus each scalar multiplied by the other's vector component, which I think is what I wrote. Should be B. Okay, so the reason we need this is because we can multiply quaternions together to apply consecutive rotations. So what I want to do now is multiply this twist quaternion into the tangent space. So, okay, so this transforms tangent space in the terrain. Oh wait. Oh no, it's tangent space on the card into world. So we could do something like that. And we'll just rotate around the up vector and the card tangent space. So float for root quaternion is, so it's opposite order. So rotations are applied in the opposite order that they're multiplied. So we first want to twist it and then convert to world space. So okay, and I just realized the naming scheme here is a little weird. Oh, you can't do that in. I'll just use that scheme. Okay, and then set both of them to the root. Okay. Oh, that did work. Okay, so now everything has a random angle again, and even on the slope, it's rotated the correct way. Okay, so now we're about ready to do the tip rotation, and so what I want to do here is I already have like a bend, about bend angle. Float for. So I want to actually bend these forward a little bit. Angle axis quaternion, get sprout, bend, angle, seed, and then okay, we'll just say the maximum bend angle is pi divided by 4 for now. Okay, so for the tip, so it's kind of, I need to apply, oh wait, I need to put the, so we're going to bend along the x-axis in tangent space, and so I need to apply this like, so it needs to twist first, then bend, and then convert to world space. So Well, I was gonna say there should be a different root and a tip, but actually we can put the bend part in the root because it won't actually move off the ground because it's just bending along. Let's see. Oh, actually, yeah, we do, because when we interpolate, that'll be how we get a smooth curve, I think. So, yeah, I'll have to see about that, actually. So anyway, that, and then maybe I should bend first. Let's see how this looks. Incorrect number of numeric type arguments. Oh, I keep on forgetting the dimensionality. Okay, I don't see any bending at all. Oh, because I don't assign the tip to anything. Okay, yeah, I did do it out of order because you can see some of these grass blades are kind of like bending, like they should only bend forward, and these are like bending to the side, if that makes sense. So I think I have to... Okay, so we have to bend first, so I just flip these. Did that do it right? It's kind of hard to tell. I think so. Yeah, I think it's right. It's kind of like there's an illusion that some of them... Okay, well, I guess this makes sense. So if you think about it logically, they should bend forward first, then rotate, and then we rotate it, or then twist, and then we rotate it into world space. Okay, well, I wanted to actually get to win today, but I guess I've never really worked with Quaternions and shaders that much, so there's a little bit to do. But I think next time we pretty much are ready. We'll have to just add some to our blade shader. We'll have to add tessellation so we can try the slurp on the grass. Let's see, I kind of want to do that now, but I don't think I should. I think it'll take longer than I can stream, so we'll work on that Friday, and I'm hoping that doing the slurp will give a nice curve instead of it just like doing a linear interpolation where it would stay flat. So I'm hoping that it'll kind of add a curve to the blade, and then after that we can try wind, which basically just another rotation because we know the wind direction in world space, and so we'll just apply that rotation to the end, but only on the tip. But anyway, I guess I better wrap it up. Thanks everybody for coming by. I really appreciate it. Like I said, Friday we'll be back for more grass stuff, and I think we'll probably just keep working on this until we're done, and then maybe I'll start on something I kind of want to work on like a toon shader. It's been a while, and I'd like to update my current one. Although maybe by then Unity will finally fix that shader graph bug. So yeah, a few possibilities, but yeah, if you enjoyed this stream, I'll put some links in the chat, so feel free to interact with me on any of my accounts there. I do have a YouTube channel where I post game development videos, so yeah, for sure take a look at that. And have a great couple days, and I'll see you Friday. Bye bye.